Okay, let's be real. Have you ever looked around your messy kitchen and thought, why isn't a robot doing this for me yet? I mean, we see them in movies all the time. Well, a new AI model from ByteDance called Robix might just be the breakthrough we've all been waiting for. It's built to be the brain that could finally make helper robots a reality in our homes.
It's a totally fair question, right? We've got AI that can compose music, create incredible art, and write poetry. But ask one to fold the laundry or put away the groceries. Turns out that's a whole different level of difficult for a machine. And that really gets to the heart of the problem. You can't just talk to a normal robot like you would a person. You can't say, hey, clear the table, but, leave my coffee mug right there. They just can't handle those complex requests. They get thrown off by interruptions, and honestly, they lack the basic common sense that we humans use every single second without even thinking about it. So how do we close this massive gap between the robots we were promised in science fiction and the ones that exist today? Well, a lot of researchers are convinced the answer isn't in better hands or legs, it's in a much, much better brain. And that brings us right to Robix. This is the new model from ByteDance, and it's designed from the ground up to be that exact thing, a single, unified brain for the next generation of robots. So what does that actually mean? Well, think of Robix as a single AI model that does two things incredibly well. Vision, it sees the world through a camera, and language, it understands what you're saying. It's built to be the high-level thinker, the cognitive engine of the machine. Here's the easiest way to think about it. Robux is the brain. It's the manager. It figures out what to do and why. It hears your command, it comes up with a plan, and then it sends super simple little instructions down to the low-level controller. That's the robot's body. That controller just focuses on the how to physically move an arm or close a gripper. Brain and brawn, totally separate. And this is where it gets really, really cool. Robix isn't just a machine waiting for orders. It's proactive. If you give it a vague command, it'll actually ask you questions to clarify what you mean. It can handle you interrupting it in the middle of a task and then get right back to it. And it has that common sense reasoning it needs to plan out these long, complicated jobs with lots of steps. But wait, how do you even teach an AI to be this capable? I mean, this is seriously advanced stuff. Well, Roblox's intelligence all comes down to a really clever three-stage training strategy. Okay, here's how they do it. First, it goes through what's called pre-training. This is where it builds a solid foundation, learning the basics like how to understand 3D space. Then, it's fine-tuned by basically watching and learning how humans and robots are supposed to interact. And finally, the secret sauce, reinforcement learning. This is basically trial and error on a massive scale, which teaches it to make sure its plans are logical and actually work from start to finish. Now, of course, making big claims is one thing. You've got to back it up with proof. So the researchers decided to throw Robixel into the ring with some of the heaviest hitters in AI, including models from giants like Google and OpenAI. So the big question is, in a controlled, offline test, did this new brain actually manage to outthink the big guys? Well, the data tells a pretty fascinating story. Let's break this down. We're looking at how accurate the AI's plans were. Now, ID means tasks it was familiar with, and OD means tasks it had never seen before. And just look at the numbers. Across the entire board, the Robix model, that's the one in bold, consistently beats both GPT-4o and Gemini 2.5 Pro. That's a clean sweep. But the most impressive number on this entire chart is this one, because it tells us something absolutely crucial about how Robix thinks. That 11.8%, that's its advantage over Gemini on tasks it has never seen before. This is huge. It proves Robix isn't just memorizing a bunch of solutions, it's actually reasoning and generalizing its knowledge to new situations it encounters. That's a game changer. Okay, so doing well in a simulation is great, but we all know the real world is messy, unpredictable, it's a whole different ballgame. So the researchers did the ultimate test. They put Robix in control of a physical robot to see how it would handle the pressure. And they didn't give it easy jobs. They tested it on a whole range of practical, everyday chores. We're talking about clearing a table, organizing groceries, packing bags at a checkout, and even sorting food based on dietary restrictions. You know, the exact kinds of things you'd want a real helper robot to do. And once it was in the real world, wow, the performance gap got even wider. This chart shows how much of a given task each AI could actually complete. Robix nailed an impressive 92.5%, putting it clearly ahead of Gemini and leaving GPT-4o way behind. And to quote the paper directly, that 92.5% is over 4 points better than Gemini and a massive 28 points better than GPT-4o. You know, in the physical world, that is the difference between an assistant that's genuinely helpful and a gadget that's just frustrating to use.
So, after all that, what's the big takeaway here? Does all this data mean you should expect a robot to be doing your dishes next week?
Not quite. But the big takeaway is that creating a single, unified brain like Robix, one that can see, understand, reason, and interact all at once, is a monumental leap forward. We're moving away from clunky, pre-programmed machines and toward truly adaptable partners that can actually function in our complex, messy human world. Look, this doesn't mean a robot is showing up on your doorstep tomorrow, but it does suggest that the core AI technology is finally getting powerful enough to make it a question of when, not if. Which really just leaves us with one final thought. How long do you think it's going to be?
All the information we've gone through in this explainer comes from the research paper Robix, a unified model for robot interaction, reasoning, and planning. Thanks for tuning in.